Hello everyone, welcome to the solution of LeetCode problem 523 named continuous subarray sum. In this problem, we are given an integer array nums and integer k, and we have to return true if the given integers array has a good subarray, or we have to return false otherwise. Now, a good subarray is a subarray where the length of is at least 2 and the sum of the element of the subarray is a multiple of k. Now let us consider the first example. Here we can see that the array contains 5 elements, which is 23, 2, 4, 6 and 7. So here the summation of these 2 and 4 will be 6. So it is a continuous subarray of size 2 and 6 is a multiple of the k, which is also 6. That's why we have to return true. Now, in the second subarray, or in the second example, the array contains 5 elements, which is 23, 2, 6, 4, and 7. So now, all of the elements summation will be 42, which is a multiple of 6. So here, we have to return true. But in the second example, there are no continuous subarray which is the multiple of k. That's why we have to return false. Now the array length can be in between 1 to 10 to the power 5, and each of the array element can be in between 0 to 10 to the power 9, and their summation will be 0 to 2 to the power 31 minus 1. And the value of k can be in between 1 to 2 to the power 31 minus 1. I hope you understood the problem statement. Now let's move on to the algorithm. Now, we have taken the first example, which has 5 elements in the array, which is 23, 2, 4, 6, and 7. And the value of k here is 6. So here, if we take this subarray in the consideration, their summation will be 6. So 6 is the multiple of 6. That means if we perform the modulus operation between the summation and the value k, which is also 6, so the remainder will be 0. So this is the mathematical part. Now let us try to understand how can we solve this problem by using some of the standard algorithm. So here, let's take a map data structure. Now, we have to calculate the prefix sum and perform modulus operation with the k. Now suppose currently we are at this position 23. So here 23 modulus of 6 will be 5. So here we will store 5 and the current index position is 0. As we know that the index of the array starts from 0, so it is 0, 1, 2, 3, and 4. Now, what this means, or what does this entry means into the map? Here, 5, 0 means in our given input array, there has a prefix where the summation of all of the element of this prefix and their modulus with k has the value 5, and this prefix ends in the position 0, which is this. So here, the 5 is the remainder, and the key is the remainder, and the value will be the last position, which is LP. So now, suppose we are at this element 2. So here the summation of 23 plus 2 will be 25. And the modulus of 25 with k, which is 6, will be 1. So the entry will be 1 and 1. That means in our given input array, we have a prefix where the modulus of the summation of all of the element with k will be 1, and those prefix ends in the index position 1. So here, this one. Now we are at this element 4. So here the summation of all of the element from 0 to 4 will be 23 plus 2 plus 4, which is 29. Now, if we perform the modulus operation with 29 and 6, it will be 5. But wait, we have already an entry which is exactly equal to 5, which is this. Now again, we have found another entry where the prefix sum and their modulus operation will be 5. What does that means? Here, try to solve or understand the pattern. In our first pattern, this prefix has the remainder 5. Now, this prefix also has the remainder 5. That means the element in between, which is 2 and 4, their summation is multiple of k. This is the basic mathematics. That means, I repeat again, this subarray has the remainder 5, and this subarray also has the remainder 5. In this case, the rest of the element here, it should be definitely multiple of k. So here, this is the basic intuition. We have to calculate each of the prefix sum starting from the 0 position or the current position or the starting position, and store 2 of the values in the map. The first value will be the remainder value, and the second value will be the ending position of the corresponding prefix. Now, if in any of the iterations we have found a duplicate remainder, that means the rest of the element will sum up to the multiple of k. So here we have to simply return true. Otherwise, we have to simply return false. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named check subarray sum, which has a parameter vector and a k. Now, we are using a prefix variable and a map. Now, we are iterating each of the element from left to right and calculated the prefix sum, and current prefix will hold the remainder of the current prefix sum with the k. Now, if our current prefix is 0 and k is greater than or equal to 1, that means we have already found a prefix from a starting position. In this case, we have to return true. Otherwise, if we found the corresponding remainder value into the map, that means the remaining element will be sum up to the multiple of k. That's why we have to check whether the difference of the current position I and the value of the corresponding prefix is greater than or equal to 2 or not. If it is, we have to return true. Otherwise, we have to simply make an entry of the prefix with the value I, which is the index position. Now finally, if anything does not return as a true, we have to return false. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, The time complexity is big O of n because we have to iterate each of the element of the given input. And the space complexity is big O of n because we are using extra map, and in the worst case, the size of the map can be equal to the size of the input array. That's why the space complexity is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.